Welcome back, my dear students, to chapter 11, the good mathematical part of chapter 11. And we will have here specific topics we will talk about and hope that we will cover it within this within this time or with this few hours. So here we go. We'll share the screen here for an example. Actually, this um, we depend here on the periodic review system. Periodical review system. What meaning of the restocking level means from a time to time, the management, especially in the inventory, with the inventory, they have to check the levels of the stock. So if it came to a point uh, where the stock is going lower, we have to substitute this stock with another stock. So we have to order instead of the ones which went out of the inventory. Like as example, if you are in have in and out. So if there is too much consuming from the inventory, we have to cover it back or recover it with another inventory so that we won't be in a shortage or out of stock. There is a rule that help in doing this, which is here. You are P plus L. This one means average demand during the recorded reorder period of time. That is the average demand, which we used always, or which we always take from the inventory or from the stock. The QPRPL, the standard deviation of the demand during the order period. Z is the number of the normal distribution curve, and we will get the Z value from the degree of the confidence. Like if you tell me 95% degree of confidence, then I will see the respond value in front of it. It's usually 1.96 and put it and multiply it in the standard deviation of the order. So like this, it seems that it's very hard, or it seems uh, like it's hard for you to understand it, that this is the average use and this is the standard deviation multiplied by Z tabulation value. So when it comes to you with an example, then you will understand it. But when I tell you something, when you see 90%, 95%, 99% in the example which we will give you, you don't take multiplying this. No, no, no. You will multiply on the Z value itself here, the correspondence value. If I tell you with a degree or a confidence of 90%, then you will multiply by 1.28. 95%, you will multiply by 1.65, etc. So this is the way it works. Let us see this example. It will show us what we are talking about. It will tell us what we are talking about. Every 10 days, a delivery person stops and checks the inventory level. It's only one line, though the example is very big. Always in the probability distributions examples, the example itself is like a story, like 5-6 lines, whereas the answer of the question is only about one line. So it's saying a delivery person stops and checks inventory levels and places an order that is delivered 3 days later. Okay. Average demand during the reorder period is 250. Here we go. The word average is the mu, which is the first thing. Okay. So let me take here what I will use in this example. I will write it on the board, then we will use it later on. Every 10 days, a delivery person stops and checks the inventory level and places an order that is delivered 3 days later. That's fine. Okay, that is very good. Perfect. That's very perfect. Okay. So what? So he stops and checks the inventory level every 10 days. So n here will be 10. But we don't need this thing now for the moment. N equals 10. We don't need it, but we need after this. Average, average will be the mu. Mu will be the average. The average is what? The average is mu, or let's say average. Average. When you see the word average is mu, and this is equals 240 tons. Equals in the example 240 tons. Like you see here, the average is the mu, which is mu is 240 tons. Overlay time is 13 days. The overlay means the time of the use of it is 13 days. That's fine. We don't need anything from this. Standard deviation, and this is another thing which we want now. The standard deviation, this is sigma, or the sign of the standard deviation is equals how much? Equals 40. 40. Okay, 40 tens. Grocery store, so the standard deviation equals 40, this one. So the sigma is for the standard deviation and it equals 40. Grocery store wants inventory on hand to meet the demand of 95%. Okay, then Z I said, Z value of 95%, Z value of 95%, which is I have to go to the schedule, to the table, and see 95% in front of what? 95% in front of 1.65. So 90% tabulation equals 1.65. So those are the data which I will take from this example. Now I will go to the resolution of the example. I will go to the resolution. So I will need the board. Again, you read already, and in front of you here, we say that the number of days are 10 days. Every 10 days, there is checking for the stock volume. And the average, or the average use, is 240 tens. So the average mu, we call it mu, 240 tens. While the standard deviation of this period, the standard deviation, I will give it sigma, it will be 40. Then he wants, the question is, what he wants here. What he wants. Let us see. He wants grocery, he said, groceries inventories. So we determine, we need to determine uh, the required, or how the amount of reordering, how much it will be. So, like you see here, uh, in front of you, what we will do is simply we would say the R, or requested or required, the required amount, R will equal mu. We can make mu like this, or we can make it like this if you want. Mu plus Z multiplied by sigma. Okay, that is how it works. Let us see. So R will equals the mu, or the average, is 240 tons, plus Z is the table value of 95%. We know it from the example, 95%. So the value is 1.65 multiplied by, this is multiplied by the sigma. Sigma, or the standard deviation, is 40. Is 40. And that will give me, as in the example, it will give me, sorry about that, it will give me 306 tons. When I finish it, it will be 306 tons. Okay, the explanation of this now, let us see the explanation of this will be as follow. So you can read the explanation. What does it mean? The explanation is the 306, which is in front of you here on the board. If the next time the delivery person stops by, he counts 45 tins, okay, we will order the quantity 306 minus 45. This is the quantity 306 minus the 45. That will be 261 ton. Okay, and this is the solve of this example. It showed me what I will do: mu plus z, the tabulation, multiplied by sigma of the order for the period. Okay, we'll go to the next. The second very important relationship here, we call it the economic order quantity, EOQ. The economic order quantity means the quantity of the stock which I have in my inventories, and that will reduce the total costs to the lowest costs. It will be the lowest cost I have. I know that the costs are holding costs and acquisition costs. For any inventory, we have many kinds of costs. All together will be the total costs. The EOQ is the amount or the quantity of the stock which will make the costs in its lowest levels. Okay, and it's also the optimal amount that will satisfy all my needs from the goods or the semi goods or semi finished or raw materials. It will satisfy all my needs within the time of the production. So this is what we call it, economic order quantity. Actually, the rule and is very easy. The equation is very easy. Q stand for the economic order quantity. D, the demand for the year, the annual demand. S stand for the cost per order or the ordering cost, divided by hold, which is holding cost for 1 unit, holding costs for only 1 unit. So like you see here, it's very easy, and applying it is very easy. All this is under the root square. All of it is under the root square. Okay, that's fine. Let's move on to see an example of it. And it's just, I will tell you, determine the economic order quantity. If the Q, the order was as example, the order quantity was as example, like blah, blah, blah. And the annual holding cost, blah, blah, blah. And the annual demand, blah, blah, blah. And the ordering cost, blah, blah. So you will just substitute in this equation, and you will give me the economic order quantity. The only thing I want you to know is that the economic order quantity is that quantity which recognize or satisfy all the needs which we want in the company, and at the same time it make the costs, the holding costs and the acquisition costs, which are the total costs, it make it on the in the lowest level. So no lower cost than this on on the economic order quantity. Like I told you, here are the costs and here are the revenues, and here are the total, sorry, the total costs here, holding and acquisition costs. So in the economic order quantity, see here the total, this is the bottom of the curve, which means the lowest costs. Like you see here, it will be the lowest costs. Okay, here an example in front of you for it. Uh, you are in charge of ordering items by department stores. The annual demand is 4,000. The annual holding cost is $15. The ordering cost is $50 per order, and the ordering quantity is 1,000 fans. And we need to get your proceeds or order fans, your times a year in quantity of 1,000, right? Okay. So to get the quantity or the amount of 1000 of the 1000, the holding costs for the year and the ordering costs for the year. So this 1000 is the order quantity divided by 2. This 2 is constants. So this will give me the average. The average I will multiply it by the annual holding cost, which is $15, plus plus the annual demand divided by what I want in the quantity order, and this will be multiplied by the holding costs. The holding costs, which is $50, or the for the ordering cost will be the $50. Like this is the ordering cost is 50. Those will give me how many orders? Okay, by applying dividing 4,000 by 1,000. So this will give me all 7,700. This is the predecessor order fans 4 times a year. If I will do it for 4 times a year. What I care about more now is how to apply to get the economic order quantity, which is, like we said, substitute directly in the equator. 2 by, this is the order yearly, the annual demand is 4,000. Then $50 is the costs, $50 is the ordering cost, by divided by the $15 of annual holding costs. Okay, this will give me the economic order quantity. Okay, this will give me 160, which rounds to 160. So I will round it to 163. That's why I will stop for the 163, as it is the optimal order every time. It should be not more than 163 units. So this is what I will give you, the economic order quantity, and you calculate it for me. Okay.